Hi YouTubers, welcome to another episode of Malcontent Corner, the corner where I hope to enlighten your lives by sharing with you things that I've learned in the daily walk of mine. Today I'm going to cover a power drain issue that developed in my 1997 Chrysler JXI convertible and what I had to do to fix the problem. Coming up next. As I stated in my intro, my Chrysler convertible started having a power drain issue, which I thought was kind of weird. I had just replaced the battery several months before, and the car had been working fine. And then one day, after sitting for about 4 or 5 days, I came out and I found the battery dead. Not thinking much of it, I recharged the battery and went upon my way. I thought maybe I left the light on or something of that nature, although I double checked everything and I didn't seem to recall anything being on. But what had happened is that I drained it, charged it, drove it, parked it, left it, came back, it was drained again. Not completely, but to the point where the solenoid on the starter was just clicking. That started me down a path of trying to troubleshoot what the problem was. Now, before we get into the troubleshooting, I'm going to go over a little basic safety items regarding the multimeter and how to use it. Okay folks, in full disclaimer here, if you are in any way intimidated by electricity, you don't know what the difference is between AC and DC and current and anything like that, I highly recommend follow the disclaimer at the beginning of the video. Leave this to the professionals. You know, you can destroy a DMM, a digital multimeter that is, you can hurt yourself and destroy your car in the process. So what I'm showing you here is just what I did, and it's for information and entertainment purposes only. Now, the first thing I did was in hooking up this car was, this is a crudely drawn circuit here of your car battery. The 12-volt positive lead goes to the power distribution center, which is a stud underneath the hood of the car. And then you have your negative lead here, which goes to a grounding stud on the apron of the car. And what I would do was I would hook up I would disconnect the power lead from that grounding stud, hook a jumper cable up between the negative cable and that grounding stud, and in addition to that, in parallel, I would hook up my DMM. Now the reason for doing that is every time you kill the power to the car and plug it back in, there are a lot of computer systems that are going to fire up, so you're not 100% certain what the current draw is going to be. So by putting this jumper cable in here, you're effectively sharing the load between the DMM and this main little jumper lead here, and allowing all the circuits to power up and for the car to sit into a steady state of affairs before removing this from the circuit. Now once you do that, all your power runs through this meter here. So I strongly recommend when you start off using the amp section of your DMM, make sure you are actually in the amps section and not in the milliamp section. Take a reading to see what your power draw is before you start measuring anything in the milliamps. Okay, so that's what this jumper cable does, is it allows you to hook this up, and then effectively removing that cable forces all the power through the meter here, which is why you want to be in amps and not in milliamps. Now, in my case, I found out that my car was drawing about 15 milliamps. And I want to make an important point here. Once you are in milliamps, do whatever it takes to make sure you do not open and close the car doors. The reason being is opening and closing the car doors turns on the dome light and may start some computer modules up that you don't know about, and your current draw may go through the roof again and pop the fuse in the milliamp section of your meter. What I highly recommend doing, and what I ended up doing, was putting painter's tape on the door handle itself. along with a note that just said no with a big exclamation point, so that way I wouldn't inadvertently open the car door. Now, the reason why I ended up doing this is that I don't drive this car every day, and because of that, it would sit there for several days at a time, and I would just not think about it, right? The car would sit there, I'd have the meter hooked up, and if I wasn't careful, I would go out and just unthinkingly open the car door, which would drive the current up to over an amp, which would pop the fuse of the meter. I did that once, and that was like, doy, okay, put a note on there, put the tape over the door. So once you're in the milliamp mode, only work on things from the firewall forward of the car. Do not start opening the door. Certainly don't try cranking the car over with one of these DMMs in series. You'll blow the fuse on or the meter up real quick. There's a reason why cold cranking amps of a car is basically in triple digits. So anyways, once I was in milliamp mode, I worked from the firewall forward, and the problem is that the car kept showing a 15 milliamp draw. And I was like, okay, and I try to troubleshoot it, pull some fuses, nothing really changed. I put it all back together, drive it. Sure enough, a couple more days later, everything was drained again. I tried doing voltage drops across the meter, across the fuses. Nothing was really showing up. But I'm going to take you outside and show you what I ended up doing, at least on this car, that helped me diagnose this problem. So let's head on outside. Okay folks, here we are underneath the hood of the Chrysler. Just going to cover a few things here for academic purposes. This area here is called the Power Distribution Center. This is not to be confused with the quote-unquote junction block that is mentioned in the Chrysler repair manuals. The junction block is the batch of fuses that you access through a panel at the end of the driver's side of the dash. You open the door, you'll see a panel there. You pull that panel, there's a bunch of fuses. That's the junction block. This is the power distribution center. So when you pull this cover off here, there's a layout of fuses here. Here's a bunch of fuses here, 20 and 40 amp, and down here a bunch of 10 and 20 amp fuses, as well as a row of relays. Up here you have the positive lead for the battery, as well as a lead that leads to the positive stud on the alternator, and up here you have the ground cable that goes to the negative side of the battery. Also under this air plenum, it might make note that there is another cover under there that has 4 relays in there. I'm not going to access that because it's not really pertinent to the problem that we're going to be discussing today. Now, in troubleshooting this problem, I did what a lot of people did. I took to Google and did an internet search, and I found a lot of people talking about the trunk light. Well, maybe the trunk light's on. Well, it's a possibility. It wasn't in this case. I also heard people talk about the power amp for the radio that sits underneath the passenger seat getting wet and shorting out and creating a power draw when the car is off. So if you've had an interior that's gotten soaked, I would highly recommend maybe looking into that. That was not the problem in this case. I did disconnect the amplifier and it did not make a change whatsoever. I felt bad for one poor soul because they took their car to a mechanic. The mechanic ended up pulling this fuse here, which is the transmission control module fuse. They left it sit for a few minutes, plugged it back in. They heard this relay momentarily click. They didn't, quote unquote, think that was right, so they were going to order a new transmission control module. So just so you know, if you pull this TCM fuse and wait a few minutes and plug it in, yes, it will click. Also of note, if you have an ammeter hooked up and you pull this TCM module, when you hear that ammeter click, it will be quite common for the car to draw a few more milliamps of power for a few minutes afterwards. I want to say roughly 5 minutes. In this case, when I would pull the TCM fuse and plug it back in, the car would draw upwards of about 65 milliamps for about 5 minutes, and then it would settle down. Now, as I described inside with the whiteboard, basically every time I was working, I was pulling this nut, pulling this cable here, hooking my meter up in series, as well as with the jumper cable, and taking a measurement. Well, I wasn't getting anywhere. I was chasing my tail around. So what I ended up doing was creating a bracket that would allow me to easily disconnect that negative cable, but still allow me to maintain power to the car. And that bracket looks something like this. What I would do is pull this negative cable here, bolt it onto here, and tighten it all up. And then I could put this on there like that and tighten this down with this nut on top of it. I mean, obviously this is not the way it fits in there, you know, because this would all be gone. I could bolt this down, and then when I wanted to disconnect it, I had a nice flat circuit here to put an alligator clip on that I could clip to one lead of the meter, and I could clip the other lead of the meter to like this wire here or some other ground, and I could basically disconnect this from the circuit. So this was a lifesaver. Once I did that, I was able to drive the car for a couple days and then pull this off and see what was going on, and I found that the car was drawing almost an amp of power after a good hour and a half of sitting there, which is not normal. Like I said, every time I was breaking the circuit, it was only drawing about 15 milliamps. But after driving it, I found I was drawing closer to an amp. I came under here, I did a few checks, pulled a few fuses, minor difference. But when I got up here, I pulled this fuse here, and the power draw went down to about 15 milliamps. So what was that fuse to? The seat belts. That's right. That fuse here controls the seatbelt control modules. And once I pulled that, everything went back down to normal. All right, that's it for under the hood. Let's head inside and we'll wrap up. Well, there you have it, folks. Once I pulled that fuse to that seatbelt module, everything went back to normal. The car was drawing about 15 milliamps, and it was only due to this little bracket that I made that it ultimately saved my bacon. What I realized is what I suspected was happening after, chasing my tail around, is that I have an intermittent problem. And sure enough, every time I was pulling that negative lead off of that ground stud, everything would power down. I'd hook it back up, everything would power up, and it would act normal. It would be completely normal until I drove the car. And then sure enough, once I drove the car, that seatbelt module would misbehave and keep power going to the seatbelts, and ultimately ending up draining the battery. Now, what is that seatbelt circuit and how does it work? On the Chrysler Sebrings, the seatbelts are actually, and the mechanisms are built into the seats themselves. And that seatbelt module, there's actually two sections to it. A section that is fed from a power lead from the ignition switch, and a timed section. Now the time section works like this. When you open and close the door, the computer of the car recognizes that there was a change in the state of the door from closed to open to close. And what it does is it tells that seatbelt control module, okay, turn on the timer circuit. And what the timer circuit does is it energizes the solenoids in those seats so that you can pull the seatbelt out and across your chest and clasp it into the seatbelt clasping mechanism. And if you go and open the door and get in the seat and put the seatbelt on and don't do anything else, you just sit there for about 20-25 minutes, what will happen is that seatbelt circuit is supposed to turn off, and the solenoids will de-energize, and the seatbelts effectively lock in whatever position they are. So you will not be able to pull them out anymore. Now don't worry, you're not trapped. They will retract, so you just unclasp them and they will retract, but you can't pull them out anymore. Now that's how the timer section works. The other section works off of a feed off of the ignition switch. So when you are in the start run position, the module goes, okay, I have a 12-volt supply from the ignition switch. The timer module is not in play here. So those solenoids will remain energized and the seatbelts will remain unlocked as long as the car is running. So if you're at a stoplight, you can lean over, the seatbelt will pull out. It does not lock at all unless it senses a change in G-force, I imagine. There's probably some sort of an inertia system in there. I did take it out after the car out, I should say, after disconnecting that fuse, and went down an isolated road and slammed on the brakes, and the seatbelts did lock like they should. So as far as I can tell, that seatbelt timer section is more of a convenience item. It allows you to get in the car and put on the seatbelt before you turn on the ignition. For me, it's not a really big deal. I just get in the car, start it, and then put on the seatbelt. So it's not a big showstopper for me, so I may not end up replacing that module. I think it's about $100. It's in the center console there, which means that would have to come out. And for me, it's why spend the $100 for a convenience item? Like I said, all I have to do is start the car and the seatbelts work like they should. But truthfully, I still had a problem even after isolating that circuit. And what I thought was that, oh, maybe this isn't the problem. So once again, I went back to my handy little bracket here that would allow me to disconnect that negative lead off of that grounding stud, but allow me to easily keep that meter in series so that the car never de-energized. And what I did was I drove the car for a couple days and I parked it and I pulled this bracket off of that main grounding stud, and I just left the meter hooked up and it was drawing 15 milliamps. And I was like, okay, well, that's kind of weird because I know the battery seems to be draining after about 4 or 5 days. But because I don't need to drive the car every day, I said, okay, I'm just going to park it. And I left it there for about 4 or 5 days, actually 6 days now that I think about it. And at day 6, what I did was I went out, I hooked this back onto the grounding stud, tightened that nut on it, went to start the car, the starter just clicked. So during this time, I was spot checking it. It was drawing 15 milliamps. So what I suspect happened was in the long and arduous process of troubleshooting this power problem, admittedly, I didn't have the car on a battery tender. I should have, but the battery discharged on me several times. And because of the events of life, I wasn't diligent about putting a charger on it. I didn't have a battery tender on it. So the car would sit there discharged. And unless you have a deep cell, car batteries do not like to be completely discharged and charged up a lot. I don't know how many times it discharged on me. It was all part of the troubleshooting process. Like I said, I don't drive the car every day. I really didn't work on this problem every day. You know, I'd work on it for a little bit, get sidetracked with something else, and then return to it. And ultimately what I ended up finding was that the battery itself was either worn out or damaged from being discharged so many times. So initially what was going on was that seatbelt controller module was not turning off like it should. It was draining the battery down. Once I removed that fuse, okay, that took care of the initial drain problem, but at that point the battery was damaged to where the power would drop off anyways if the car sat for more than 6 days. So I'm glad to say that I've subsequently have put a new battery in the car. I have not replaced that fuse on that seatbelt circuit, and as of today, I can leave that car sit for 3-4 weeks and still go out and fire it up. The battery is as fresh as a daisy. So again, using this little bracket here helped out a lot. Now that's what I have for you here on this episode of Malcontent Corner. I hope that you found it of some use, especially if you're dealing with a power issue on your Chrysler JXI. But that's what I ended up having to do to fix the problem. It was an intermittent problem, and it wasn't until I was able to effectively put my meter in series with it and see what the current draw was before I was able to troubleshoot it, and this little bracket saved the day. So, as always, I appreciate you listening to me. I hope you found this of some use. I hope to see you back again here in the not too distant future. So until then, you take care of yourselves, and we'll see you later. Ciao!